Right? So I'm going to do one thing at a time there. Look at this. If I say 1 plus 2 cos b plus cos squared b, what can this thing simplify into? Look at this. You can see, like, if you are used to the factorization, you can see that if I expand this, I will say 1 plus cos b and 1 plus cos b. Look at this. If I expand 1 times 1, it's 1 times cos b times 1 is 2 cos b. So you see that this is actually that. So actually it's 1 plus cos b squared. See that? Hence they put it under a square root. That is that. So now we can now write this part and say, since I'm taking my left hand side, let me take it here to say my left hand side, it will be equal to. Hello, our most developed student. My name is Confident and welcome to our 24-minute lesson. This is the ultimate guide in maths, science, career guidance, as well as a sneak peek in my personal experiences. This is a channel that is designed with you in mind. Let us dive into today's lesson. Hi Isabella, how are you? And I hope this is our mathematics N3 video, and I was supposed to be having you today, but unfortunately I think you said you were tied up. But I will continue the lesson and you'll get a recorded video of this lesson. And just to recap on what we have been doing concerning the mathematics N3, our ultimate guide, let's look at the topics that we've covered, and at the same time we will know where to take it from here. So we've looked at the factors and factorization, the equations, the exponents and logs, and then the simultaneous equations, word problems, and manipulation of formula. We looked at the analytical geometry, coordinate geometry. We looked at calculus. That was yesterday. Today is the day where we are looking at graphs and trigonometry. So we are in day 4, and then tomorrow is, to me, is the big day where I will say bring your questions and your answers, and then I'll be able to attend to them. So that is that. Now let me dive to the part where I'll expect the lesson to be. This is what we've been doing, and then calculus, and then graphs. So this is where we are now. I just want to lay a little bit of foundation whenever one is to if you're looking at algebraic graphs, there is a little bit of foundation that I want us to focus on, to say what do you need. I think, let me lower this. So what do you need to know, just as a base whenever you're dealing with graphs. So when you are dealing with graphs, remember, as I said, you'll be doing 2 types of graphs, and the first one is a parabola, right? And then with this graph you are saying f of x is equal to ax squared plus bx plus c. And then when you're looking at this graph, you are looking at a graph that is of a shape, if you are having it as your x and your y here, I'm looking at a graph which, number one, it can normally it can be a graph that is shaped like this, remember, and it can be also a graph that is shaped like this. So now for the graph that is facing up, we say a is greater than 0. Okay, for the graph that is facing down, we say a is less than 0, meaning is a is equal to negative, and then here a is equal to positive, right? So you need to understand those types of graphs. And then when you are drawing this graph, whether it's the parabola or hyperbola, I mean of cubic graph, let's come to the cubic graph. Cubic. Now the cubic graph is also similar in the sense that it's f of x is equal to ax cubed plus bx squared plus cx plus d. See that? So now this graph, now being a cubic graph, when you are sketching it, you have also two types of this graph. I'm just going to show you now. So it's very important for you to have an idea how that particular graph comes out. So the first type of the graph, it can be of this version. Especially for your N3, you might find a graph like this, or you might find a graph like, okay, you might find a graph maybe like this. See that? So these are the two types of graphs, where this here is a is greater than 0, meaning a is positive, and then the other one is a is less than 0, meaning a is what? Is negative. So those are the types of graphs that you're going to form. Usually they give this type in your N3, whereby you have got those 2 points that are important there. If I can mark them, that point and that point and this point, as well as that point, the intercepts. So now when you're drawing the graphs, the quick thing that I want us to remember is when they say sketch a graph, there are some areas that I want you to do. Number one, you need to find the x-intercept. Alright, now in the x-intercept, remember y is equal to 0. Number two, you find the y-intercept. Alright, so in the y-intercept, again, remember x is equal to 0. And then number three, you find the turning point of the graph. These are the common ones that you find. In the turning point, you find your dy over dx, and you equate that to 0. And then number four, the shape of the graph. You determine the shape of graph, and that's it. Number five, you sketch. So these are the points that you can follow up. At this stage, you are able to sketch. So whenever I'm going to be going through the lesson on the graphs, I'm going to be focusing mainly on these points, and I'll be referring back to these points. Now, yesterday we did, if you remember yesterday's lesson, we did a question. This was the question that we did. This question, we actually looked at the first part, 5.3. I just want to erase a few things. I don't want to lose everything here. I just want to erase a few things here, but we looked at 5.3, and 5.3, it was saying consider the following function, and then that was that, and says make use of differentiation to determine the coordinates of the turning points of f of x. So if you're forgetting, just refer to the previous lesson, the video of that lesson. But what we did, we said the coordinates of the turning point, if you still remember, we started here. So f of x is equal to this, and then we found f prime. This is where we find f prime x. We differentiated, and then we got this, and then from here we said at TP, that's what I want you to remember, at turning point f prime x is equal to 0. So they said determine the coordinates of the turning point. You see, it's the same part of y number turning point, y number 3, to say at turning point dy over dx is equal to 0. So that is already a step there. And then we did that. We got two values, x is equal to 0 and x is equal to 1. And we also said this is not the coordinates, these are the x values. To find the coordinates, go to the original, and in the original you substitute for x is 0 for x, and then for x is 1, and we got these coordinates. Now these are turning points coordinates. Alright, now the next question here, we're going to take it from there. It says calculate, this was supposed to be x and y intercepts. You see, calculate x and y intercepts. You can see it follows the same thing. X intercept, y intercept is actually following the same stages, but they just mix them up here. So if I can find the x and y intercept, what I'm gonna do here, let me just give it a place here. Let's say I'm doing it here, the x and the y intercept. Remember I said x-intercept, what happens when you say x-intercept? You must remember y equal to 0. So when y is equal to 0, you come here on the original graph. That is your f of x. If f of x is equal to 0, so what you'll be having here, you will have a 1 over 3x cubed, right? And then minus, this is minus 1 over 2x squared is equal to what? Is equal to 0. You see that? Because that's your f of x. And then from there, you need to solve for x. The easier thing is to factorize, take out x squared here. And then when you're taking out, you say x squared is common. So you have got 1 over 3. When you pull out x squared, it's x minus 1 over 2. And this is equal to 0. So either x squared is equal to 0 or 1 over 3x here minus a half is equal to 0. And then you take this to the other side. You have got 1 over 3x is equal to 1 over 2. Right. Then you multiply by 3, multiply by 3, so that you can have your x now. What is your x? X is equal to 3 over 2. And by 3 over 2, we are saying what? This, since we're going to be plotting, this is 1,5. Right. It's better to put it like that so that you can understand what it means. And then on the other side, when we're saying x squared is 0, even if you square root this side, it means x is equal to 0. Now remember, it's plus or minus, but the square there, it means x is equal to 0 twice. Because you're supposed to get 2 answers there. Alright, but I will explain that further so that you can understand what it means. But it's more like you've got x squared is equal to 0. It's like a difference of 2 squares. Just to show you this, it's like you're saying x squared minus 0 equal to 0. Just that 0 cannot take any square. But here it's more like you have got, remember, a square must have 2 answers, but here it's x being 0 twice. Okay, from here, that was the what? That was the x-intercept. Let's find the y-intercept. So the moment you say y-intercept, remember the condition. You say what? X is equal to 0. So we come back here on the original. There is the original to say 1 over 3 here. So f of x, again, is equal to 1 over 3x cubed minus 1 over 2x. Now when x becomes 0, that is f of 0, x is 0, then you can see that everything becomes 0. So it's 1 over 3, 0 cubed minus 1 over 2, 0. So this thing actually becomes 0. Okay, so now when you write that, you're gonna have again, if I'm to write these in coordinates form, remember now, how do you write coordinates form? I'm going to write them like this, to say here when x is 0, y is 0 twice, right? We say it twice. And then here when x is 1,5, y is 0. And then the other coordinate again is the same thing. When x is 0, y is 0. See, these are the coordinates that you need to plot. And the other coordinate that you need is this one here, which says when x is 0, y is 0. When x is 1, y is what? Negative 1,6. I mean negative 1 over 6, which is more like 0,3333. I think if you use that. Alright. So now, how do we then plot this? Remember, it's a sketch. They don't expect you to draw like an accurate graph. They just want you to sketch this graph. So if you have to sketch a graph like that, so this is what you'll be having, where you have now something like this, which you need to definitely show us this is your y, this is your x, and then identify the points. Now the first one is the turning points. Okay, let's start with the intercepts. I think it's better. The intercept 0 and 1,5. So in here I've got a point here, 0. Let me use that one. I have a point there. I'll make it red. I have a point there, and I can make this other point here being what? 1,5. They want to see that point. It's very important. So what are these? Remember, These are the intercepts. That's where the graph is going to cut. Now, it's very important again to remember the shape of this graph. We said it's positive. So you expect now, if you look at the graphs here, being positive, I'm expecting it to shape like that. This one. Alright, so let's go on. This is a cubic graph. Next one is the y-intercept. Again is at 0, 0. Look, the x-intercept is 0, 0. Y-intercept 0, 0. Turning point again 0, 0. And the other turning point is 1. We said 1 over 6 is negative 0.33. So when x is 1 here, y is negative 0.33. You can just estimate there and say maybe it's somewhere here. So this, remember, this is 1,5. So I expect my 1 to be more like here. This is 1, and then my turning point can be somewhere there. So now when I'm drawing the graph, you know, you need to have kind of a shape. Let's bring that shape again. We said it's a graph that is shaped like this. So if I look into this graph, you can see if I'm to have a shape like this. Now look at the shape of this graph. I'm going to plot here. This is the shape of the graph. I will have it to come and touch there. It will come and turn. And then after turning, this is what you're having. See that? So this is your graph of f. Are you with me? And then here you need to indicate. They will tell you here to say, in this graph, sketch the graph and show the calculated values in question 5.3.1 and 5.3.2. So they want to show now the values. It's your duty now to come and say this one, the turning point is 1, negative 1 over 6. They need to see that point. Here already you showed that this is 1,5. They want to see that. And then here they want to see the 0 there. And basically that is what they want to see. Those are the points that are showing in that graph. And then that is the graph of f of x. Okay. Now let's look at another one which will be similar in approach, but now a little bit different in the sense that I brought the one with a negative. Alright. Look at this. Now when it says given f of x is equal to that, you are given, this is what you are given. Right? Says determine the coordinates of the turning point. Same thing. You are given that. First 5 marks, determine the coordinates of the turning point. So what do you do there? What you have is you are given f of x is equal to 24 minus 2x cubed. Alright. Now coordinates of the turning point. The moment they say turning point, remember what I said? When you see the word turning point, you must show at the turning point here, f prime x or dy over dx is equal to 0. So first you must find f prime x. That's the first thing. So what you do here, let's find f prime x, which will be f prime x is equal to, I think the first thing is to, let's arrange this in the right way. Did I write this down properly? It's 24x. There is an x here. So let's rearrange this. You know, it's that with a cubed, so it's minus 2x cubed. The way they wrote it is just to confuse you there. So it's negative 2x cubed plus 24x. Are you with me? So therefore, if you find f prime x there, it's minus 2. You drop the 3, and then x, what are you gonna say? 3 minus 1, and then plus 24 times x. This is 1 minus 1, which is 24 times 1. Then equal to 2 times 3 there, which is negative 6x squared plus what? Plus 24. And then you have to state that statement to say add TP f prime x is equal to 0. You need that statement so that it can now justify why we are saying minus 6x squared plus 24 is equal to 0. Then take 24 to the other side, minus 6x squared is equal to negative 24. Then from there, remember here we're solving for x. Divide by negative 6, divide by negative 6. When you do that, you have got what? X squared is equal to, when you divide there, 6 into 24 is a positive 4. Now to find x, it's plus or minus square root, remember. Therefore, x is equal to plus or minus 2. This is what? This is the value of x at the turning point. X is plus 2 or minus 2. But remember I said this, you need to find the y value. Now you take the original equation, which is your f of x. So f of x is equal to negative 2x cubed plus 24x. And then we said when x is equal to, let's start with the positive 2. So f of 2 is equal to negative 2 and then 2 cubed here plus 24 2. See that? Then it will give us the answer. Let's do that to say what is the turning point when it is that, which is negative 2 bracket 2 cubed, seeing that, plus 24 bracket 2. Alright, so you get 32. That's the first part. And then if you have to put it in coordinate form, what do you have? You have when x is 2, y is 32. That's the first turning point. The second turning point, again you repeat, f of what? Negative 2 now is equal to negative 2 bracket negative 2 cubed plus 24 negative 2. See that? Equal to, you do the same thing, it's a repeat, but in this case it's now negative 2 bracket negative 2 cubed plus 24 bracket negative 2. Are you with me? Then it gives us what? This one, when I'm doing this, it is giving me actually a negative 32. Let me just be careful there. It's negative 2 minus 2, that's negative 32. Let me change that negative to a positive just to also see that it's still the same. 32 is okay. This one gave me a negative 32. Again, the coordinates are minus 2 minus 32. So these are turning points, TP and TP. Okay, so the question was determine the coordinates of the turning point of f of x, 5 marks. So for you to write it like this, these are the coordinates of the turning point. Next one, calculate the x and y intercepts of f of x. See, a repetition of the previous question. So when you look at the x and y intercept, let me work it further this way. Now remember what I said was, when you're talking about the x-intercept, what must you remember? Here, y is equal to 0. So you write your f of x is equal to negative 2x cubed. It was negative 2x cubed plus 24x, right? Plus 24x. Now, at turning point, this is equal to 0. So you can actually take off this to solve now for x. So what do you pull out there? I think you can pull out a 2, even a negative 2, whatever case. Let's pull out 2, or let's factorize 2x there. There, if you put a negative, it's even good. Negative 2x. Doesn't matter how you want to do it, but you can, x is the common one. Oh, let's just focus on x, just for argument's sake. X is common there. What you'll have is minus 2x squared inside, see, plus 24. That is equal to 0. Therefore, x is equal to 0, or this inside there, negative x squared plus 24 equal to 0. Take 24 to the other side, is minus 2x squared is equal to negative 24. Divide by negative 2 here, divide by negative 2. When you do that, you have got your x squared is equal to the negative neutralized there, you have got 12. I think that's x squared, am I right? Is equal to half of 24 is 12. Then from here you square root both sides, square root both sides. So x is equal to plus or minus square root of 12. Then you can say plus or minus what? Let's find the square root of 12. So you can say here square root of 12 is 3.464, which is 3.464. These are the x-intercepts. So they ask you about the x-intercepts, then you can say x-intercepts are these, and the x-intercepts are this one. Are you with me? And then y-intercept, my spelling there. Remember, at the y-intercept, what did you say? At the y-intercept, x is equal to 0. So you come here, you can see that if you put x in f of x, if you put x is equal to 0, this thing becomes 0, because here you'll have 0, you'll have 0. So everything becomes 0. So if you look at the y-intercept here, you write it y-intercept, you're going to say f of 0 is equal to negative 2, I think it was 0 cubed plus 24 0, then equal to 0. Right, there it is. Then when you have done this, you can plot your graph. Now let's plot the graph. Am I right? Yes, we've done this. They sketch the graph of f of x and show the calculated values in question 5.2.1, 5.2.2. Okay, this was the 5, which means in 1 and 2 there in this case. So let's look at this. If I'm to plot that graph, let me try to make this as big as I can. I'm comfortable with white. Let's try to make this graph as big as I can here. And remember, these are my what? My y values. These are my x values. Now focus, remember this is a sketch, it doesn't have to be accurate. Focus on making it more realistic at the same time, but you don't have to be like very accurate to that. Let's start with the intercepts. So the intercepts, turning point, leave them out. Let's go to the intercepts. There is the intercept. The x-intercept first, x is 0, and then 3, almost 3,5, plus or minus 3,5. Those are the intercepts. So the first one you have here being 0, right? So if I can call this a 1, a 2, a 3. So if you can say this is 1, this is 2, this is 3, this is 1, this is 2, this is 3. So minus 1, minus 2, minus 3, and then so there is negative 4. Even here it will be 4. So 3,5 is almost there, and minus 3,5 is almost there. So this is where the graph is going to be cutting. See, it will cut on these 3 points. And then next again, they are saying this is the x. Let's look at the turning points. The turning points, we did put them to say the first turning point is 2. When x is 2, y is 32. When x is 2, so you can actually look at it like this to say it as a sketch. Remember, this is more like 10, 20, 30. You can just do that. 10, this is 20, and this is 30. Do the same thing up. 10, 20, and 30. It's not really necessary to what I'm doing now, but just to kind of have a feel that it is more accurate. So when x is 2, y is 32. Let's look at this point here. I think there is a point somewhere there. That's our turning point. I'll make it yellow. This is a turning point. The other one, it was what? 232, and then it's minus. Actually, this is wrong. This is wrong. It says when x is 2, y is 32. I was supposed to draw it up. When x is 2, y is 32. It's somewhere up here, there. I'll make it like this. This is 2 and 32. That's the first one. See, I'm already writing it in coordinate form. The other one is minus 2 and minus 32. Is also somewhere down there, which is negative 2, negative 32. This is another turning point. I've already wrote that. So now you ask yourself, remember we said this graph is what? This graph is negative, and if you remember, we come back to the shape of a negative graph. We go back, we said a negative graph kind of looks like the one that we're having here. So if I can use that shape here to say a negative graph is more like having a shape like this. Let's try to bring it in close. Let's try to have a shape of this graph in here. How will this graph try to shape up? We are trying to come up with a shape like this, and remember the turning point. So if you have to draw your graph, am I right? Actually, maybe my shape is the one that is wrong, because it's showing me a different shape here. Look at the graph actually. So this might not be the right shape, but look at the shape that I'm getting here. This is the shape. See, it will cut there, it will turn there, because this is a turning point. It will go and cut there, and then it will go and turn there, and then it will go and cut like that. So this was actually, so this is the shape. I think I mixed them up then in the other part. So this is the shape of a negative. So the positive is the other way around. Okay, I see now. So this is now just correct. A is greater than 0. This kind of shape is when A is less than 0. So this is our graph of F. So now when they say you need to show the points, the fact that you have there as 0, you have shown the point. In here you must write 3, 5, and then in here you must write negative 3, 5. You need to write negative 3, 5 there. Okay, I think it's fine there where I wrote it, because they said show all these calculated values. So that is what they mean. And you have got this. Label your graph. Please make it clear. Label the graph. This is graph of F. Turning points are labeled. Turning points are labeled, as well as the intercepts. So that is where you will be able now to score all of the 5 marks into that. All right. So that is that part. And then let us move on to the section on trigonometry. Trigonometry. Now there are some concepts that I will say they are important in your trig. For example, the concept of the right angle triangle, the trigonometric ratios using SOHCAHTOA. These you need to put your foundation on. The trigonometric ratios using X, Y, and R, the cast diagram, the inverse of trigs, the angles of elevation and depression, as well as trigonometric proofs. So these are the things that we'll be going through in this particular lesson. All right. So let's start our lesson here by looking at the proofs, identities. So I'm still waiting for my student. Okay, says 8.1, use basic trigonometric identities to prove that cot x is equal to 2 sin squared x over these. Proofs, trig proofs. So what do we do here? Not a problem. This is what you do. Use basic trig identities to prove. This is what you are having. You are saying cot x is this. You have to choose now the left hand side or the right hand side, and you can see we have more of the what? Of the is the right hand side. I'm left handed, so I usually confuse this part, but of the right hand side. So you're going to say right hand side. Right? So let's write the right hand side. 2 sin squared x all over 2 tan x minus 2 sin x cos x is equal to, now remember you're starting from the left hand side. Now you have to identify a few things. Remember this needs to become cot. You have to identify a few things already that we have. For example, look at this one. You need to identify the identity here, and the identity says sine 2a is equal to, what does it say? Is equal to 2 sin a cos a. See that? So this is what we're having there. That is that part. But at the same time also look at 10 x is equal to what? Sine x over cos x. Sine a, that is 10a, sine a over cos a. So those are things that you are in a way identify. But now let's change tan instead, because you see if I change this to sine 2a, it's not going to solve me anything. I'll be forced to take it out again. So even let's solve 10 first before we factorize this. There's going to be factorizing here. So this was going to be 2 look at this, 2 sine squared x, right, over 2 sine x over cos x minus 2 sine x cos x. Are you with me? Then from here, look at this. I can then factorize. I can take out that sign, which is equal to, but I'm not going to just take out sign. I'm going to take out 2 at the bottom. So you have got 2 sine squared x. You can see that sin x is common. I'm going to pull it out there. It will be 2 sin x. What do you have inside? So inside, since it's gone, it's more like I'll cancel there to remain with 1. This will cancel to remain with 2 cos. You see what I'm saying? So that's what you're going to have. So it is going to be here 1 over cos x, right, minus cos x, I think, because sine is out. I've taken out sin x there. Seeing that. Then from here, I am in a position then to cancel out the sin x and sin x, as well as 2 and 2. So what do I have? I'm now having 1 over, then you have got now 1 over cos x minus cos x. Are you seeing that? Then from here, you continue, equal to, I made an error. I see you picked up. There are 2 here, sin squared. So it means I'm left with what? 1 of them here, sin x, because it was squared. So I cancelled 1 is left. That one, it's good that I picked that also quicker there. So you have got sin x. Please remember it was squared. And squared means there are 2 of them. In other words, by squared it means it's 2 sin x times another sin x. That's what squared means. So when you cancel out 1, you remain with the other one. Okay, that's why I'm saying there is 1 that remains here. Then from here, what do? Let's look at what we can do from here. We can move on and simplify this fraction at the bottom here. Get rid of this fraction, and the fraction there is over 1 here, and the common denominator at the bottom is cos x. I see that. Then you can say over, say cos x into cos x, it's 1 times 1 is 1 minus 1 into this, it's cos x times cos x. So you need to remember your fractions here. When you're dealing with your fractions, take it down. Even this thing got down, equal to, and then it's not done. Then all over on top there was sine x. So this part here, this part is this part. To say common denominator is cos x, it's cos x into cos x, it's 1 times 1, you multiply by that top, that's why I had 1. And then you do the same thing to say 1 into cos x is cos x times the top is cos x. Alright, from here, that's what I was saying. From here you can move on and say equal to, here it's equal to sine x, right, over cos x is 1 minus cos squared x, right, and then all over cos x. Are you seeing that? Then you continue. Now remember this part, 1 minus cos squared x is back to the common identity, which says what? Sine squared x plus cos squared x is equal to 1. Then take 1 this side, cos squared, it's sine squared x is equal to 1 minus what? Cos squared x. Are you seeing that? So that is what you are having there. So this is actually sine squared. See that? Then you continue and say this will be sine x. Then I'll use this part divided by, so that I can have this division line here. This division line here, I'm using it as divided by, then it's what? Sine squared x over cos x. You know why I'm doing it? So that I can be able to say equal to sine x times, see when you flip it, I can say cos x over what? Over sine squared x. See how I mean when I'm saying I can flip it. Then from there, I can able to cancel. The sign goes, but they are squared here. Only 1 and sin x will remain because it's squared. So at the end, even if I scratch it out, I will say sin x is remaining. So what am I having? Yeah, I'm having cos x over sin x. And then this is cot. Now, remember 10 is sine over cos. Now, cot is cos over 10. This is cot x, which is equal to my left hand side. That's what they were talking about. I know I did it a bit long, but that's it. It was going, flowing. All that part was flowing into that part. Alright, now moving on to the next one again. It's trigonometric identity proofs here. Look at 8.2 says use the basic trigonometric identities to prove this part. That is 5 marks. Now look at this. I'm saying you need to study it actually. Look at what they've given you and try to study what is it that you are given and work from there. So it says square root of 1 plus 2 cos b plus cos squared b. It's under square root, so there might be a reason there. And then at the bottom, sine to the power 4b plus sine squared b cos squared b is equal to this. So obviously you can see that I have got more meat on the other side to chew, so I'm gonna take the left hand side. There is more to do there. Alright, so I'm gonna do one thing at a time there. Look at this. If I say 1 plus 2 cos b plus cos squared b, what can this thing simplify into? Look at this. You can see, like, if you are used to the factorization, you can see that if I expand this, I will say 1 plus cos b and 1 plus cos b. Look at this. If I expand 1 times 1, it's 1 times cos b times 1 is 2 cos b. So you see that this is actually that. So actually it's 1 plus cos b squared. See that? Hence they put it under a square root. That is that. So now we can now write this part and say, since I'm taking my left hand side, let me take it here to say my left hand side, it will be equal to, so let me continue there to say, if you give me that, and then I will have square root of, then I can have bracket 1 plus cos b squared. See how the square root will go all over. Again, look at the bottom there, sine squared sine 4. Let me factorize sine squared b. Let me take it out there. Then because it's 4 there, I'll left with sine squared b plus cos squared b. See that identity? And inside there is just 1. Then continue, equal to, that one falls off. I have 1 plus cos b at the top because the square root of a square, is just 1 plus cos b. And then over, this becomes 1 over sine squared b, then times 1, which is equal to, you can do that, 1 plus cos b. You are back to say, remember what they say, you mustn't lose sight of what they're saying you're proving. It's 1 over 1 minus cos b. Okay, let's not lose sight here. Sine squared, you can now, since you want to take it back, you've got 1 plus cos b, I see now, over, you ask yourself, what is sine squared? You come back to that identity. Remember, sine squared b plus cos squared b equal to 1. You see, take this to the other side, so you've got sine squared b is equal to 1 minus what? Cos squared b. And this is a difference of 2 squares. Remember this one, difference of 2 squares, if you put a square there, is 1 minus cos b and 1 plus cos b. See that? So that's what we have here as bracket 1 minus cos b and 1 plus cos b. I see that? Then from there, equal to 1 plus cos b, 1 plus cos b, which is 1 over 1 minus cos b. and I think that's what they did, which is equal to what? Which is equal to my right hand side. Again, these are proofs, and you just need to be comfortable with the way you deal with the proofs. Now, I want to lay a foundation here. That's where I just want to pause a little bit and say, let me lay in some foundation. It says, use basic trigonometric identities to simplify the following. 6 marks. Now, in here, the way I want us to work on is to work this out, but while we are working this out, let me come with a cast diagram, because that's where the foundation of this, all these questions, I'll maintain my cast diagram. Now, the cast diagram, what does it say? It says you have got 0, you have 90, you have 180, and then this is a bit long. We have what? 270, and then after a complete revolution, 360. You see, I'm moving like this, anti-clockwise. So this is my quadrant 1, my quadrant 2, my quadrant 3, and my quadrant 4. And the reduction rules, in here you have got 90, this is before 90, 90 minus theta. After 90, it's 90 plus theta. These two, we call them, they link. We call them what? Cofunctions. You use them when you're dealing with 90, but common ones is this one, 180 plus theta. Then in here, minus theta in the first one. Sorry about that. It's 180 minus theta. After 180 is 180 plus theta. These are the common one. Then before 360 is 360 minus theta. Very common. Now it says what? Our cast diagram says all students take chemistry. Our cast, you see, C-A-S-T. This is our cast diagram. Now this is what you use as your reduction rules. Now if you come here and you say to me, what is, let's study this thing the way they brought it. It's just so mixed up. It's so mixed up. So I'm going to do it individually, so, and then pull everything together. For example, if you ask me what is sine 180 degrees plus x, I will say in here, which quadrant is this sin 180 plus x? Quadrant 3. And what is sin? 10 is only positive, so this is minus sin x. See how I simplify that. Next one, cos x squared, blah 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 blah. But let's start with the insight without hurrying. What is cosec? Cosec. Cosec is 1 over sine, then it will be 1 over sine 360 minus x. See that? That's what I'm having. And then if they say squared, you do this. That is cosec squared. Are you seeing that? So this will be equal to 1 over, now sine 360 minus x, come back to 360 is the fourth quadrant and sine is negative. This is also minus sine x, but you put a squared, which is equal to now positive, which is 1 over sine squared x. I want to maintain sine, I don't want to work with cosec. Alright, and then after that, let me see, do I really need to work with cosec? I'm just debating here, cosec squared x minus 1. Let me leave it like this. We will look at it later because there is a square root again on it, but I think it will work out fine. Or actually, let me deal with it. If I say now, therefore, if I say, remember I've got minus 1 inside there. If I say cosec, okay, it is okay, sorry about this. If I say here cosec squared, and then it was what? It was 360 minus x, then minus 1, then equal to, remember cosec squared became 1 over sine squared x. This is how we simplify it. This guy here became this guy, right? And then what? then minus 1. Can you try to simplify this? Let me see if you can simplify, which is equal to, from here I can say this over 1, and then I can say sine squared x is common there. Then I'll say this into this, it's 1 minus sine squared x. See this, which is cool. So what is 1 minus sine squared x? You remember that part, this part here. Let me use another one here, this part, to say cos squared x plus sine squared x. Remember, this is equal to 1. I'm just working now backwards. So to say, if I take sine squared to the other side, it will be 1 minus sine squared x is equal to cos squared x. So you can see that this is actually cos squared x over what? Sine squared x. I think here, if I knew this cos x squared x minus 1, I think there is an identity here. I think there is identity of 10, but let's stick to what I'm given. Let's stick to this trig. So in here you can see that this will be square root of this part here, which is not a problem. Now next one, let's come here. 1 plus tan squared, this is interesting to say actually. This is sec squared, just that I don't have my formulas, but I'm gonna work it in a way. Let me try to work it from here to say here square root. Let me look 1 plus tan squared here. Let me do that. 1 plus, this is 1 plus tan squared 360 minus x. See this? Now 1 plus tan squared 360 minus x. What you need to remember, again, the angle, cos 360 minus x, 10 is negative. So what will I have here? This is same as saying 1 plus bracket, this is negative tan x squared. You see, just like we did with cos. Remember, with cos, we said cos squared is 360. We put a square inside, negative was inside the square. So even here you do that, which symbol becomes 1 plus tan squared x. But this is just sec squared x. Sec squared x. But now I just want to check whether my I'm doing this right. Let's continue it. Let's say I don't know this part, but I think there's an identity there. But let's say I don't know this part. I convert these to, yes, I convert these to say equal to, let's continue and say equal to 1 plus sine squared x. Remember 10 sine squared x over cos squared x. This is over 1, which is equal to cos squared x here. So what is it? It will be cos squared x. 1 into cos squared x is cos squared x plus cos squared into cos squared times 1, which is sine squared x. See this? I don't need to cram that identity actually. Cos squared plus sine squared is 1 over cos squared x. Now what is 1 over cos x is sec. So this is sec squared x. So I was correct on that identity. Alright, so the next one is cos 180 minus x. I'll work it this side to say if you give me cos 180 minus x here equal to, now 180 minus sine is positive, cos is negative, so this is simple minus cos x. I sing that. And then cot is what? 1 over 10, that cot 1 over 10 180 plus x. See that is equal to, it's 1 over, now 180 plus x, 10 is positive there, so it's 1 over 10x. 1 over 10x. But remember, when you deal with sine and cos, it will be cos x over sine x, because this is cot x at the end. Are you with me? So now when you do this, you now take everything that I've been doing and what you simplify it now from everything that we've been writing. You are able to kind of simplify and write everything once, to say from here it was this became minus sine x. Now I want to write it at a place that can be fast, so this is here, it's minus sine x, put brackets now when you're writing. So that was the first one, it became minus sine x. Then the one which was the square root of cos x squared x, this minus 1, we did this to say I'll write the square root for now, so dot square root, and then but it's simplified as cos squared x over sine squared x, remember. So it became cos squared x over sine squared x. Alright, so this was this part. And then this one in here, square root of 1 plus 10 squared, remember 1 plus 10 squared became sec squared. So in here also it was over, am I right to say this is done on the side? Yes. So it's over here, over square root of sec squared x multiplied by cos 180 minus x is this one, which is negative cos x, and multiplied by negative cos x, and you also further multiply plus cot this, which is in a way cot x. Let me just say cot x out of interest here, cot x, but I'll change it for cos over sine because I still have sec there. So when I simplify this, it is negative sine x, right? Then from there times, you see square root of cos squared over sine x, so this is simple cos. Now you must also see, look at this, cos over sine is here, cos x over sine x is cot, so this is actually cot, this one, this is cot. So in a way it's square root, so it is cos x over sine x, which is cot x here. The square root, remember, is gone, so it's cos x over sine x, or cot squared, square root of cot squared is that, over, I continue, I'm seeing that it makes things easier for me. Then in here, square root of sec squared, it's sec x, but sec is 1 over cos x. You know why I'm doing it? Because I want to multiply by that negative cos x, see that, times cot x. So I'm just looking at things that will make things faster and easy to simplify. So how do I go? The cot is gone, this is gone, this is gone, the negative is gone, and the answer simple is sin x. Someone will ask, is it possible to prove this thing that you did well, right? For the sake of this lesson, I'm not going to prove it, but I will encourage you to, you can prove it. Let's try. Okay, let me rather not prove it. I'll show you how you can prove the next one, which is much simpler, because there is a lot of this and this and this and this, but this is what it simplified as we were working. But someone might argue and say, try prove it and see. Let me try prove this here. So let's choose any value of x. Let's say x is equal to let's say 40 degrees. Let's use 40 degrees out of argument's sake. We try to put this in the calculator. We need to be very sensitive here. It's too full, but let's try. Fraction. Now sin 180 plus 40. Remember my x is 40. Right, times, then square root of, now if you say cosec squared, that, remember, it's fraction, I can't have cosec, it's 1 over, now bracket, because it's multiplying already. Let me put the bracket before here, because it's a square letter. So it's what? It's sin 360 minus x, which is 40. You just have to be careful. Close that bracket and close this one because it was squared. See, minus 1. Alright, go down. Okay, that was not as bad as I thought. Square root of 1 plus, again 10 squared, put a bracket, and you say 10 360 minus 40, close the bracket and close this one, then you put a square, alright, times cos, again is 180 minus 40, close, times cot, put a fraction, which is 1 over 10 180 plus 40, close that bracket, equal to, must not give me an error, it says minus 1,28, minus 1,28, minus 1,28. See, that is giving me a negative already, which is suspicious of my answer, because my answer was positive. So I need to find out where must I have made an error. It means there is an error somewhere that I made. So let me check again. If I put this 1 plus 10, okay, it's square root of 1 plus 10 squared times, everything is multiplying, the top one was sine this, times square root of that. Okay, there is that. Did I put a square? Yes. And then I put minus 1. Yes. So far so good. Which is square root of 1 plus 10, 360 minus 40. This thing was squared. It was squared. Yes. Okay, I see where I made wrong. See, everything is still under that square root. So let me delete this. I see where I did wrong. Let's delete this. Let's delete this. I see where you see anything you do here, you might get things out of line. That was tan squared. Then play forward so that it's times. Mustn't be under the square root. Again, it's following me the square root. Times, yes, like that. Cos, I think that's where I made an error. 180 minus 40. Right, close, and then times, then fraction, not under square root, 1 over 10, 180 plus 40, right, equal to, I'm getting 0,6427. I hope this is fine also. 0,6427, 0,64. Now that one was sine 40. Let me say sine. Remember the answer was sine x. If you say sine 40, 0,64. Yes, this is what I got. So it's correct. Check, just check, because it was sine x here. Just do it on your side and see whether it's that, but it did give me the answer there. It's correct. Alright, now look at the next one. Just to look at this part again, make use of trig identities to prove the following. We are proving that this is this. Now, this one I brought it in because it involves 90. And 90, I'll take it back to our cast diagram. 90, I told you, is cofunctions. And cofunctions, what you need to know about cofunctions here, the moment you say 90, let me write them down. To say, if you say to me with cofunctions, cos 90 minus x is equal to sine x. That's a cofunction. And then sine 90 plus x, I'm just giving you different types, is equal to sine becomes cos x. But cos, actually sine 90 plus x, and then cos 90 plus x. Which quadrant is that? Remember, it's the second quadrant, is equal to minus sine x. Cos is negative in that quadrant. Cos, if you take it there, cos 90 plus. So if you're saying what is cos here, cos is negative here in the second quadrant, 90 plus. Hence, it's minus sine x. Then the other one then would be sine, which is sin 90 minus x. This one is also cos x. These are the cofunctions that are very, very important. Now, let's work this out. If you give me in here cos squared 90, now you see 90 plus x, you have seen here to say this is negative sin x, cos 90 plus. So what you do is I put a bracket and then I say cos 90 plus, this is negative sin x squared. I think that over sin 90 minus x. Where is sin 90 minus this? Cos x. So this is cos x plus, now what is don't know why they made it so much. What is 1 minus sine squared? Now here you repeat again to say cos squared x. You put it as part of your working, plus sine squared x equal to 1. And then you say here, take this to the other side to say cos squared x is equal to 1 minus sin squared x. I don't know why they made this 7 marks, because it doesn't look complicated. So this is actually cos squared x. Oh, by the way, you are asking which side did I choose? I chose my left hand side, which is equal to, now the square there, it's sin squared x over, now look at this. At the bottom I can pull out cos, factorize cos x. I have got 1 plus cos x. Right, and then at the same time equal to, it's very interesting the way they were doing this thing. It's very interesting. Look, sin squared, I just said sin squared. This time I'm going to use this one to say sin squared, take this to the other side. Use this, take this to the other side to say sin squared x is equal to 1 minus what? Cos squared x. See that? So in here you can write that now to say equal to 1 minus cos squared x over cos x 1 plus cos x. I think that, which is equal to difference of two squares there. You open your two brackets, which is what? 1 minus cos x. You must remember these kind of things. And 1 plus cos x all over cos x 1 plus cos x. See that? Then 1 plus cos x, 1 plus cos x. That's the thing. Then at the end of the day, what do we have? Equal to 1 minus cos x over what? Over cos x. Then what we have done, I think that's the 1 minus cos x over cos x, which is equal to what? Equal to our right hand side. Managed to simplify it into that. That is that in this part. Alright, now we're moving on to something different than the first one. Now this one is saying calculate the values. You are solving now for x. Calculate the value or values of x that will satisfy the equation, and you're given the domain values of x there between 0 and 360 if this. Now again, this comes back into your cast diagram, but first things first, when you're given that, you need to get your reference angle. So here you're gonna say a ref angle. What are you gonna say? Ref angle is arctan 1 over square root of 3. Then let's get the reference angle. So when you do that, it will say equal to so it will be shift arctan bracket 1 over square root of 3. Alright, then I do that and then say equal to, say 30 degrees. So my reference angle is 30 degrees. Now since I know my reference angle is equal to 30 degrees, so this is how you write your answer. We are going to say now x minus 30, right, is equal to, that's the first one, x minus 30 is equal to 30 degrees. Now with 10 you say plus k 180. Alright, and then you do the other one, or x, okay, let me come back to the cast diagram. Let's go back to that cast diagram. You go and find out where is 10 positive again. 10 is positive in what? In the third quadrant, in the fourth, in the third. Why did I do this? This is wrong. This is wrong. This is wrong. This is wrong. Remember cast diagram? This is quadrant number 1. This is quadrant number 2. This is quadrant number 3. And this is quadrant number 4. Sorry that. Correct that, please. Quadrants, I mixed up quadrants there. We are starting from 1. So now 10 is positive in the third quadrant, which is 180 plus theta. That theta is your ref angle. So you come here and say it's x minus 30 degrees is equal to 180 plus theta, which is 30, you see, plus k 180. So that's how you solve it. And then from there, take this to the other side here. You have got x is equal to, this becomes 60 degrees because it's 30 plus 30 is positive, plus k 180. Let's see whether it gives us the same answer. When you take it to the other side, or x is equal to 180 plus 30, it's what? I think it's 210. And then 210 plus 30, 210, 220, 200 is 240 plus k 180 degrees. See what I'm having here? So now, then up to you to say when k is 0. Remember, I given between 0 and 360. So therefore, here you can say x is equal to 60 degrees. That is when k is equal to 0. You see? So you can even ignore this part, maybe, just out of interest. You ignore this part, like this. You'll just get 60. Even if you're ignoring also this part, you'll get what? 240. But let me show you how it works out when you're not ignoring it. Here, if you say when k is 1, here you say x is equal to 60 plus 1 times 180. So when k is 1, you see that 180 plus this is 240. See that it actually gives you the answer here. When k is 0 here, again you're going to get 240. Now these are the possible answers that can be. So the value of x here is 2. X is equal to 60 degrees, or x is equal to 240 degrees. As I said, maybe you can just ignore this part like this. We are going to say x minus this is equal to 30. Why? Because it's in the what? It's in the first quadrant. First quadrant is that, and then also in the second quadrant you ignore this, and it will give you what? It will give you 240. So you're going to say in the second quadrant x minus 30 is 180 plus the reference angle, then that gives us 240. Alright, look at the next one again. Calculate the value or values of beta that will satisfy the equation for this if this is this. Now they give you sine and cos. If they give you sine and cos, you must know that you have to do 10. What you do, you divide. For example, I want to make 10 here. I'll say over cos b over cos b. See what I'm doing there? Cancel there. I've got 4 is equal to sine over cos is 210 beta. Now divide by 2, divide by 2. I now have my what? Then I can say 10 beta is equal to 2. What do? Get your ref angle is equal to arctan 2. That is your reference angle. Now what is arctan 2? Use your calculator then to say shift arctan 2. You get your reference angle, which is 63,435, because it's 3 decimal places. 63,435. So it's 63,435 degrees. It's your reference angle, and you remind yourself, where is 10 positive? Let's go to the cast diagram again. 10 is positive in the first quadrant and in the third quadrant. So in the first, you leave it like that. In the third, you say 180 plus reference angle. So you come here and then say, if it's in the first quadrant, beta is equal to, there it is already, 63,435. And then you say, or, now go for the what? For the third quadrant, 180 plus ref angle, which is your theta, which is 63,435. Just remember all this step is very important to say. You go to the cast diagram and ask yourself, where is 10 positive? There are always two answers where the graph is positive. Okay, so plus 63,435. Then this gives us what? 243,435. 243,435. That is it. Alright, so that is that part. And I think lastly, again, to give a further practice on this, similar, solve the equation and they give that. Now first things first, 3 cot. Let's look at this. 3 cot this. Take 2 to the other side. You have got 3 cot theta is equal to 9,5 minus 2. So divide now 3 cot theta divide by 3. This will be 7,5 if I'm not mistaken, but let's leave it like that. 9,5 minus 2 divided by 3. The calculator will do that. Then we have got cot theta is equal to what? If we take a calculator for this, it will give us 9,5 minus 2 over 3. It gives me 5 over 2. Now look how you go back. Remember, cot is what? 1 over 10. So it means 1 over 10 theta is equal to 5 over 2. Now if I'm flipping things back, even here things will flip back. It means 10. Remember, 10 and cos are reciprocal. 10 theta is simple 2 over 5. Said that this became 10 all of them. But now ref angle, back to my ref angle. A ref angle is equal to arc10, just that all of them were 10. I didn't notice that. So arc10, 2 over 5. I do the same thing here, take my calculator to get the reference angle. Remember, there will be 2 answers, one in the first quadrant and one in the second quadrant. It's the same with your cos, it's the same with your sin. So arc10, 2 over 5 equal to 21,801. So it's 21,801 degrees. This is my ref angle and it's in the first quadrant, which is positive. So far so good. Therefore we are going to say theta is equal to 21,801 degrees, or in the third quadrant is 180 plus reference angle 21,801. Okay, then it gives you the answer there. This is the value that you will get in the third quadrant, 180 plus 21,801. Alright, equal to, and then it gives us 201,801, which is 201,801. So yeah, this is how you go about if you are solving such kind of problem. And then to wrap it up for this end of our intervention, remember, as I said, it is a crash course intervention. I end up with this question, and this question I think is now part of your area, your sin rule, cosine rule, as well as using trig ratios here. Let's look at this. It says figure 2 represents a triangle ABC. Determine the size of the acute angle BAC. If the area of triangle this is this, B is that, and C is that. Now area. Now you remember the area. They say the triangle determine the size of BAC. Now you remember the formula. The formula says area of triangle ABC is equal to half AB sine C. Let me plot this so that you can see what it talks about. This is a triangle like this, where you have got A, B, C. So now remember how it's like A is this side, B is that side, C is that side. So if they say half, now AB, meaning there is this A and okay, this A, let me make it thicker. This is your A, this is your B. Do you see they form an angle? They form an angle C. Hence, half AB same C. Similarly, when you come here, if you want to find the area of this triangle, you are going to say they want that side and that side, and the angle formed is this side. So that is that. It's half. Can make it from here already. Area is half. So A is equal to half. Now, the part is BA times AC and then sin A. See that? Which is half times BA is 3 times 8 sin A. But this, they told us the area already. What is the area? It's 6 square root 3. So you can say 6 square root of 3. This is good. Then divide there. This is 4. Now it's 12. So we are going to divide by 12 or 3 times 4. Let's divide by 3 times 4 once here. 3 times 4 divide by 3 times 4. When you do that, you've got sin A is equal to this. 3 into 6 is 2. Am I right? And then 2 into 4 is 2. So it's square root of 3 over 2. Now, what is A? A there is equal to arc sin square root of 3 over 2. See that? And then which is equal to, I think it's between 30 and 60. That's a special angle. Shift arc sin square root of 3 over 2 equal to 60 degrees. Yes. There. A is equal to 60 degrees. Then say, therefore, BAC is equal to 60 degrees. Alright. That is that part. Now consider figure 3, which represents triangle PQR. PQR. RS is 10. You can see that. PSQ is 68. Which PSQ, which is this side. And PRS is 40, which is that. Now with this diagram, they're saying determine the following: the length of PS. They want the length of PS. Let me mark PS. Make it bigger there. P and S. They want that length. Alright. So how can you go about this part? Let's look at what we can do to find the length of PS. And in here you are not given much as to say how many marks. Let's look at the mark allocation. 2 times 3, so each one is 3 marks. So let's look at this. So whenever you've got 2 options here, you can use for information given, you can use, remember, there is the sine rule. Okay, there is the sine rule, there is the cosine rule, and then there is the trig ratios. Those are things that your mind must be playing around. So you have to ask yourself, which triangle am I gonna focus on? If we try to make this like this triangle, for example, this triangle and this triangle, you have to ask to say, okay, I have got that part, but we don't have, okay, make it this right, we don't have any of the sides. RS, okay, I've got RS is that 10. They didn't give us any of the other sides, so unfortunately we can't use the trig ratio here. And then if instead we focus on this triangle, let's look at this triangle. We focus on this triangle, we focus on this triangle, we can ask ourselves, now when we do that, it's easy to see that you are given, using the laws of triangles. You see this angle, this is the exterior angle. Let me continue this line. This is the exterior angle of, so this is, if this is 40, you say 40, this becomes 28. Why? 28 plus 40 is the interior angle is the exterior angle. Are you with me? Then from there, automatically I can see that we can focus on the sine rule. See that? So the sine rule is the one that can work. What does it say? You can quote the sine rule, which says sine A over A is equal to sine B over B. If I write it from what I'm given here, I'll say sine 40. Remember, is this and the side. So it's sine 40 over PS. So it's sine 40 over side PS is equal to, which one is the complete pair? Which is sine 28 over 10. That's what I think they were trying to trick you there. Sine 28 over 10. Then after that, what do? You cross multiply. This top multiplies bottom, this multiplies bottom. So you're going to say PS times sine 28 is equal to 10 times sine 40. Then after that, divide by sine 28 here, divide by sine 28. See that? Then you get your what? You get your PS to say PS is equal to, and then just do that and use our calculator to say it's 10 times sine 40 over sine 28 equal to, then 13,6. This is 13,692. So it's 13,692. Let me see the units they didn't give. It's meters. So it's meters. So it's 13,692 meters. You can even use it here. 13,692 meters is 13,692. So the next question was, they said calculate the length of PS. That's what we did. That was PS. The next one, the length of PQ. PQ. Now look at this now. Since I know I can erase now this part, I can erase this part and say to myself, since I know the other side, I can come here and say my PQ, I can use this now, this triangle. And in that, 90 degrees is trig ratios. What is this? It's SOHCAHTOA. This is now my SOHCAHTOA. You see? Then there is more like a dividing there. Then you ask yourself, which one will work? From here, you have to ask yourself, what did they give me? Number one, I've got this 13. I've got h, the hypotenuse, which is 13,692. Then I've got the angle. Now I need to identify my this is 90 degrees. Which one is my opposite? Which one is my hypotenuse? So this one is my adjacent side. See, this is my opposite side. Why? Because this line has got the 90 and the 68 is the adjacent. Are you with me? So now what am I asked to find? I'm asked to find PQ. I'm asked to find my opposite. So my opposite side, O, is the one that I'm asked to find. So which one links the two? I've got the angle, remember, S angle X, S is 68 degrees. So already when I got angle and I need O, 2 can give me O's, that and that. But hypotenuse, this doesn't have, it's sine. So here I'm gonna focus on sine. Theta is equal to opposite over hypotenuse. Then sine 68 is equal to my opposite, which is PQ, over what is my hypotenuse? 13,692. See now how this thing finalized that. Then I multiply by 13,692. Also here you multiply by 13,692, so that this goes, then you get your PQ now to say what is my PQ. Then multiply 13,692 times sin 68. So it's 13,692 times sin 68. Alright, which is 12,695. This is 12,695. Again, it's in meters. So this is, yeah, this is what you do when you use, as I said, you are working on your sine rule, cosine rule, trig ratios. This is what then it does. And then with this, like, it ends our lesson. What it is as I said, it was for my student that I was having this lesson for, but now I will encourage you to go through over everything that we have done. It is a lesson that covers everything on a trig and also on graphs, so that it can in a way better prepare you for your final exams. And then this is the end of our session. As I keep on saying to you guys also who are looking forward for the next boot camp, I will encourage you, check out our website so that you can also register for the next boot camp. It's the end of our lesson. Cheers. Thank you.